Imagine standing beneath a starlit sky, the cool night air brushing your skin, completely unaware that a pulse from a galaxy 2.5 million light years away has just reached across the cosmic void to nudge the invisible shield cradling our planet. On September 16th, 2025, something extraordinary unfolded. Magnetometers across the globe, sensitive instruments tuned to measure Earth's magnetic field, flared with a signal that defied explanation. A sharp, unmistakable spike rippled through our planet's magnetic bubble, perfectly timed with a mysterious energy transient from the Andromeda galaxy. This wasn't a random cosmic hiccup, it was a moment that could reshape our understanding of space weather, hinting that forces far beyond our sun can touch Earth in ways we never dreamed possible. This is a story of cosmic connection, thrilling and unsettling, that will pull you in and hold you until the final word. Picture a quiet morning, September 16th, 2025, with the sun resting calmly. No solar storms brewing on its surface. Scientists monitoring Earth's magnetosphere, that invisible force field wrapping our planet like a protective cocoon, anticipated a routine day, their screens displaying the usual hum of data, but at precisely 3:47 a.m. UTC, the unexpected happened. Ground-based magnetometers from NOAA's global network, ESA's swarm satellites orbiting high above, and cutting-edge quantum sensors in research labs all captured a sudden, sharp jump in Earth's magnetic field. The spike, lasting a mere 12 seconds, carried a frequency unlike any known solar or terrestrial source. Later analysis revealed something even more astonishing. This magnetic twitch aligned perfectly with a radio transient detected in the direction of the Andromeda galaxy, 2.5 million light-years away. The signal's rhythm, a repeating pattern every 3.7 seconds, forming a precise 3-to-1 ratio with the magnetic spike, suggested structure, almost intent. It was as if Andromeda, our nearest galactic neighbor, had reached across the universe to tap Earth's shoulder, sending researchers into a frenzy to decode what this could mean. This wasn't just a data point, it was a cosmic wake-up call, suggesting our planet might be far more entwined with the universe than we ever imagined. To understand the weight of this event, we need to grasp the role of Earth's magnetosphere, a massive invisible bubble spun from the molten iron churning deep within our planet's core. This magnetic shield stands as our first defense against the harshness of space, deflecting solar wind that could strip away our atmosphere or fry our electronics. Normally, this bubble sways to the sun's rhythm. Solar flares and coronal mass ejections make it flex and vibrate, like a drum struck by a steady hand. But on that September morning, something else struck the drum, a pulse from a source 2.5 million light-years away. Scientists call this phenomenon bell ringing, a concept rooted in a remarkable event from 2004 when a magnetar, a neutron star with a magnetic field trillions of times stronger than Earth's, flared in our Milky Way, 50,000 light-years away. For 7.5 seconds, that dying star's pulse made Earth's magnetic field hum like a tuning fork, its rhythm so precise that our planet echoed the star's rotation. Now, imagine this same effect across a distance 50 times greater. If Andromeda's signal could trigger a similar response, we're facing a cosmic connection that challenges our notions of distance and power. The precision of the timing, the radio transient hitting first, followed 2.3 minutes later by the magnetic spike, matching the light travel time from our outer magnetosphere to ground sensors, suggests a structured signal, not random noise. It's a rhythm that hints at purpose, sending shivers through the scientific community. How could a signal endure a 2.5 million light-year journey and still have the strength to nudge Earth's magnetic field? Scientists are exploring 3 groundbreaking ideas to unravel this mystery, each one pushing the boundaries of what we believe is possible. First, consider the resonance trigger hypothesis, where the key lies not in power, but in precision. Picture an opera singer shattering a wine glass with a single perfectly pitched note. She doesn't need to scream, just hit the glass's exact natural frequency to make it vibrate until it breaks. Earth's magnetosphere has its own natural frequencies, shaped by its size and composition. A signal from Andromeda tuned to one of these frequencies could amplify a faint pulse into a measurable spike, like a perfectly timed tap on a cosmic drum. The 12-second magnetic spike and the 3.7-second radio pattern align with theoretical resonance models, suggesting Andromeda hit just the right note to make our planet's magnetic field resonate. Second, there's the intergalactic magnetic bridge idea, rooted in the universe's hidden infrastructure. Galaxies don't float in empty space. They're linked by vast magnetized filaments of plasma. plasma, cosmic highways stretching across millions of light years. Andromeda sits at the crossroads of multiple such filaments. Its massive plasma halo, extending 500,000 light years, acting like a cosmic amplifier to focus and direct energy pulses. A signal from Andromeda could ride one of these magnetic bridges, arriving at Earth with enough structure to trigger our sensors, like a ripple gliding down a taut rope, gentle but persistent. Finally, we're in the era of quantum-grade sensors, a revolution in detection technology. Quantum magnetometers, atomic sensors, and AI-driven anomaly detection systems can pick up magnetic shifts that older instruments would have missed. On September 16th, a global network of sensors, from NOAA's ground stations to ESA's satellites, captured the event within a 6-minute window, ruling out instrument error and confirming a real cosmic event. These tools are like the first telescopes, revealing a universe far more interconnected than we ever imagined. The idea that a signal from Andromeda could reach Earth hinges on the universe's hidden architecture, a network that makes such a journey possible. Space isn't a void, it's filled with the intergalactic medium, a diffuse magnetized plasma with just one atom per cubic meter, yet structured by magnetic filaments that thread galaxies together like a cosmic web. These filaments act as waveguides, preserving the coherence of low-frequency electromagnetic pulses over millions of light years. Unlike ordinary light, which scatters and fades, these low-frequency modes maintain their rhythm, carrying the signature of their source across unimaginable distances. Andromeda's plasma halo, as revealed in a July 2025 Nature Astronomy study, stretches nearly 500,000 light years, creating a magnetized environment that focuses energy pulses like a cosmic lens. When a powerful event, like a magnetar flare or activity near Andromeda's central black hole, occurs, it can send a signal down these filaments, arriving at Earth with enough structure to trigger resonance in our magnetosphere. Imagine ocean swells traveling thousands of miles from a distant storm, gentle by the time they reach the shore, but still carrying the rhythm of their origin. This is how Andromeda's signal could have reached us, not with overwhelming force, but with surgical precision, a whisper that made our planet's magnetic field hum. What kind of cosmic event could generate a signal strong enough to cross 2.5 million light years and still affect Earth? Scientists are zeroing in on 3 potential sources within Andromeda, each with a distinct fingerprint. A hidden magnetar flare is a prime candidate. Magnetars are neutron stars with magnetic fields so intense they could disrupt electronics from across the solar system. When they flare, they unleash more energy in milliseconds than our sun produces in centuries. With Andromeda hosting an estimated 100 million neutron stars, a massive flare from one could produce a precisely timed pulse, its frequency structure surviving the intergalactic journey. The 2004 Magnetar event in our galaxy, which mirrored its 7.5-second spin in Earth's magnetic data, supports this possibility. Another contender is activity near Andromeda's supermassive black hole, a behemoth 200 million times our sun's mass. Though dormant, even minor bursts, like material spiraling into its accretion disk, can generate brief high-energy spikes. In resonance physics, timing outweighs raw power, and a precisely timed pulse could have triggered the magnetic spike we observed. Finally, dark matter offers a tantalizing, if speculative, possibility. A mysterious 3.5 kilo-electron-volt X-ray line detected in Andromeda in 2024 hints at unknown physics, with some models suggesting periodic variations that could modulate plasma flows along intergalactic filaments. These fluctuations might act as carrier waves, propagating a signal to Earth, tying this event to forces we're only beginning to grasp. This isn't the first time Earth's magnetic field has danced to a cosmic tune. On December 27, 2004, a magnetar named SGR 1806-20, 50,000 light years away in the constellation Sagittarius, erupted with a flare so intense it blinded every gamma-ray satellite in Earth's orbit. For a tenth of a second, this dying star released more energy than our sun produces in 250,000 years. But the true marvel came in the aftermath. For several minutes, Earth's magnetosphere pulsed in perfect sync with the magnetar's 7.5-second rotation, as if our planet's magnetic field was a tuning fork struck by a cosmic mallet. The signal was faint by the time it reached Earth, but its rhythm was exact, proving that distant sources can influence our magnetic environment through precise timing. The Andromeda signal, though 50 times farther away and diluted by a factor of 2,500, follows the same blueprint. Its rhythm, repeating every 3.7 seconds, hit the right resonant frequency frequency to make our magnetosphere respond, not with brute force, but with a perfectly tuned note that made our planet echo back across the cosmic void. You might wonder why a 12-second magnetic twitch deserves our attention. The answer lies in our technology's deep reliance on Earth's magnetic stability. GPS satellites depend on magnetometers to maintain precise orientation, ensuring your navigation app keeps you on track. Power grids monitor magnetic fluctuations to prevent induced currents from triggering blackouts, like the 1989 solar storm that left millions in Quebec without power. Precision agriculture and high-frequency trading also hinge on magnetic stability for their timing systems. A 0.1% error can cost trading firms millions, while a slight navigation drift can send aircraft off course. The September 16th event wasn't catastrophic, but it exposes a subtle vulnerability. Extragalactic signals could stack with solar storm effects, amplifying disruptions. Defense and aerospace sectors are particularly keen, needing to distinguish natural anomalies from electronic warfare. Quantum magnetometers deployed over the past decade are revealing these cosmic influences with unprecedented clarity, forcing us to rethink how we build resilient systems. This isn't about fear, it's about awareness, ensuring our technology can adapt to a universe that's more interconnected than we ever realized. The September 16th event is more than a singular anomaly. It's a glimpse into the universe's vast electromagnetic network, where Earth is not an isolated speck, but a vibrant node in a cosmic symphony. Beyond the intergalactic filaments and Andromeda's plasma halo, there's a deeper layer to this story: the role of dark matter and the cosmic web. Dark matter, making up 27% of the universe's mass, doesn't just sit idly, it shapes the gravitational scaffolding that holds galaxies together. Recent studies, including a 2025 paper in the Astrophysical Journal, suggests that dark matter halos around galaxies like Andromeda could influence how magnetic signals propagate, acting as a kind of cosmic lens that focuses low-frequency waves. If the mysterious X-ray line detected in Andromeda is tied to dark matter interactions, it could mean that these signals are modulated by forces we barely understand, traveling along pathways we're only beginning to map. This event hints at a universe where galaxies are not just distant neighbors, but active participants in a shared electromagnetic dance, their signals weaving through the cosmic web to reach us. The idea that Earth's magnetic field could resonate with such distant sources challenges our sense of isolation, painting a picture of a cosmos where every pulse, every rhythm connects us to the stars in ways we're only now beginning to comprehend. This cosmic event isn't just a puzzle for scientists, it's a story that touches something deeply human, our curiosity about our place in the universe. For centuries, we've looked to the stars with wonder, weaving myths and dreams about what lies beyond. The Andromeda signal transforms that wonder into something tangible, a reminder that we're part of a larger cosmic tapestry. Every time our magnetosphere hums with a distant pulse, it's as if the universe is reaching out, inviting us to listen. This discovery bridges the gap between the abstract and the immediate, showing how events light years away can ripple through our world, affecting the technology we rely on and the way we understand our planet's defenses. It's a call to curiosity, urging us to ask questions, to explore, to imagine what other signals might be out there, waiting to be heard. This isn't just about data or magnetometers, it's about humanity's relentless drive to uncover the secrets of the cosmos, to find meaning in the patterns that connect us to the stars. As we stand on the cusp of this new era of cosmic discovery, the tools we're developing are transforming how we listen to the universe. Quantum magnetometers, AI-driven pattern recognition, and global sensor networks are like the first radios tuning into frequencies we never knew existed. The September 16th event is just the beginning, a hint that our planet is part of a galactic conversation that's been ongoing for billions of years. Scientists are already planning the next steps, expanding sensor networks to capture even fainter signals, building simulations to map the cosmic web's magnetic pathways, and opening data to global researchers to verify these findings. This isn't about proving one event, it's about uncovering a systematic phenomenon that could reveal Earth's role in a universe alive with rhythm and connection. As we refine our instruments and deepen our understanding, we're not just chasing anomalies, we're rewriting the story of our planet, from a lone world orbiting a single star to a vibrant participant in a cosmic network that spans galaxies. The universe is speaking, and we're finally learning how to listen. Beyond the immediate thrill of the Andromeda signal lies a deeper, more sobering truth about Earth's magnetic field. It's not as stable as we once thought. Scientists have known for decades that our planet's magnetic field is weakening, a slow but measurable decline that could, in thousands of years, lead to a reversal where the magnetic north and south poles flip. This process, called a geomagnetic reversal, has happened many times in Earth's history, etched into the geological record of ancient rocks. But the September 16th event adds a new layer to this story, suggesting that external cosmic forces could influence our magnetic field's behavior in ways we hadn't anticipated. If distant galaxies like Andromeda can send signals that resonate with our magnetosphere, what happens when our field is at its weakest? Could these cosmic pulses amplify fluctuations, accelerating changes in Earth's magnetic environment? The precision of the Andromeda signal, its 3.7-second rhythm aligning with our magnetosphere's natural frequencies, raises questions about whether such events could nudge our field toward instability. This isn't about imminent catastrophe. Reversals take millennia, and life has survived them before. But it's a reminder that our planet's magnetic shield is a dynamic living system, sensitive not just to the sun, but to the broader cosmos. As we develop more sensitive sensors and refine our models of the cosmic web, we're beginning to see Earth's magnetic field as a delicate instrument, tuned to the universe's subtle vibrations, responding to whispers from galaxies far beyond our own. The Andromeda event underscores a pivotal moment in human history. Our technology is finally catching up with our curiosity about the universe. The quantum magnetometers that detected the September 16th spike represent a leap forward from the clunky instruments of decades past, capable of sensing magnetic fluctuations so subtle they were once invisible. These devices, paired with AI systems that sift through terabytes of data to spot anomalies in real time, are rewriting what's possible in cosmic observation. Imagine the astronomers of the 17th century peering through Galileo's first telescopes, suddenly seeing moons and planets they never knew existed. We're in a similar moment, but our telescopes are quantum sensors and our skies are the magnetic fields of Earth and beyond. The global network that captured the Andromeda signal, NOAA's stations, ESA's satellites, university labs, shows how collaboration and technology are knitting together a new understanding of our planet's place in the cosmos. This event wasn't just a lucky catch, it was the result of years of innovation, from the development of atomic sensors to algorithms that can distinguish a cosmic signal from background noise. As we push these technologies further, deploying more sensors and refining AI models, we're not just listening to Andromeda, we're opening our ears to the entire universe, ready to hear stories that have been traveling for millions of years to reach us. The Andromeda signal carries more than scientific implications. It invites us to wrestle with profound questions about our existence and our relationship with the universe. For millennia, humans have gazed at the stars, wondering if we're alone, if the cosmos cares about our tiny planet. The idea that a signal from 2.5 million light years away could make Earth's magnetic field quiver suggests a universe that's not indifferent but interconnected, where even the faintest pulse can ripple across galaxies to touch us. This event challenges the boundaries between the cosmic and the personal, reminding us that the same forces shaping distant galaxies also shape our world, our technology, our environment, our future. It's a humbling thought. Every time we detect a signal like this, we're reminded that we're part of something vast, a cosmic web where every thread vibrates with meaning. This discovery isn't just about magnetometers or frequencies. It's about the human spirit, our unyielding need to explore, to connect, to find patterns in the chaos of the cosmos. As we stand on the edge of this new frontier, the Andromeda signal is a call to embrace our role as cosmic listeners, to keep asking questions, and to marvel at the universe's ability to surprise us with its intricate, interconnected beauty. The discovery of the Andromeda signal invites us to reimagine Earth not as a solitary wanderer in the vastness of space, but as an active listener in a cosmic symphony where every note, no matter how faint, carries meaning across the universe. This event, captured on September 16th, 2025, suggests that our planet's magnetic field is more than a shield. It's an antenna, finely tuned to pick up the subtle vibrations of distant galaxies. The 3.7-second rhythm of the Andromeda signal, perfectly aligned with our magnetosphere's natural frequencies, hints at a universe where precision matters more than power, where a whisper can travel millions of light years to make our planet hum in response. This isn't just about one event, it's about recognizing that Earth is part of of a larger conversation, one that has been unfolding for billions of years across the cosmic web. The intergalactic filaments, the plasma halos, the dark matter structures, they all form a network that connects us to Andromeda, to the Virgo cluster, and beyond. Each pulse a thread in a tapestry of cosmic interactions. As we refine our understanding of this network, we're beginning to see that our planet's magnetic field is not just a passive barrier, but a dynamic participant, resonating with the universe's rhythms in ways that challenge our sense of isolation. This discovery is a call to listen more closely, to tune our instruments and our minds to the subtle harmonies of the cosmos, and to embrace the idea that Earth is not alone, but deeply entwined with the stars, part of a symphony that's been playing since the universe began. The Andromeda signal doesn't just rewrite our understanding of cosmic connections, it sends ripples through science and society, reshaping how we approach everything from technology to global collaboration. This event highlights the fragility of our magnetic environment and the need to protect the systems that depend on it. GPS networks, power grids, satellite communications, all of which are vulnerable to even subtle cosmic disturbances. The September 16th spike, though brief, underscores the importance of building resilient infrastructure capable of adapting to both solar and extragalactic influences. Beyond technology, this discovery is a testament to the power of global scientific collaboration, with researchers from NOAA, ESA, and universities worldwide pooling their data to uncover a phenomenon that no single team could have detected alone. It's a reminder that the pursuit of knowledge transcends borders, uniting us in a shared quest to understand our place in the universe. The Andromeda signal also sparks a broader societal conversation about our relationship with the cosmos. How do we prepare for a future where cosmic events could impact our daily lives? From policymakers planning for space weather resilience to educators inspiring the next generation of scientists, this event is a catalyst for action, urging us to invest in the tools, the research, and the imagination needed to navigate a universe that's more connected than we ever thought possible. As we move forward, the Andromeda signal is not just a scientific milestone, but a cultural touchstone, inviting us to rethink our priorities and embrace our role as stewards of a planet that's part of a larger cosmic story. The Andromeda signal marks the dawn of a new era in cosmic exploration, one where Earth is no longer a passive observer, but an active participant in the universe's grand narrative. The tools that detected this event, quantum magnetometers, AI-driven data analysis, global sensor networks, are just the beginning, opening a window into a cosmos filled with signals we're only now learning to hear. This discovery challenges us to expand our horizons, to build even more sensitive instruments, to refine our models of the cosmic web, and to foster collaborations that span continents and disciplines. The September 16th event is a spark, igniting questions about how often these cosmic pulses reach us, how they shape our planet's magnetic environment, and what other secrets the universe is waiting to share. It's a reminder that science is not about finding final answers, but about asking better questions, each one leading us closer to a deeper understanding of our place in the cosmos. As we stand at this crossroads, the Andromeda signal is a beacon guiding us toward a future where we listen to the universe with new ears, where we embrace the unknown with curiosity and courage, and where we recognize that every pulse, every rhythm connects us to a universe that's alive with possibility. This is not the end of the story, it's the beginning of a new chapter, one where Earth takes its place as a listener, a responder, and a partner in the cosmic dance. Just when you thought this story couldn't expand further, a new twist emerges. The September 16th event might not stand alone. Preliminary data from the same week points to a second detection window, this time aligned with the Virgo cluster, 50 million light years away. The pattern mirrors Andromeda's signal, a magnetic spike paired with a radio transient, its frequency resonating with Earth's magnetosphere. If confirmed, this suggests our planet is picking up signals from multiple cosmic sources, part of an electromagnetic network spanning the universe. This isn't just about Andromeda, it's about redefining Earth's place in the cosmos. Our planet is a node in a vast web, resonating with pulses from galaxies far beyond our own. With quantum sensors and AI, we're peeling back the layers of a universe alive with structure and rhythm. Every detection brings us closer to understanding our cosmic connections, revealing a symphony we're only now beginning to hear. This story isn't just a scientific breakthrough, it's a call to connect with the universe and each other. What do you make of this cosmic signal? Is Andromeda truly reaching out to Earth, or are we catching the universe's subtle tricks? Share your thoughts in the comments. We're eager to hear your perspective. If this tale of cosmic connection sparked your curiosity, give it a thumbs up to share it with others. And if you're hungry for more mind-bending discoveries, hit that subscribe button to stay tuned for the next chapter in our cosmic journey. The universe is full of mysteries, and together we're unraveling them one pulse at a time.